Most people driving diesel trucks have no idea that the oil protecting their engine shares the same corporate parent as the Pennzoil sitting on the shelf right next to it. Shell Rotella and Pennzoil are corporate siblings, both owned by Shell Oil Company after a massive $2.9 billion acquisition in October 2002. That purchase brought together what was then the largest independent lubricants company in America, with Shell's already dominant position in diesel engine oils. Shell paid $22 per share, a 42% premium over market price, specifically because they saw how Pennzoil and Quaker State would complement Shell's brand strength in diesel engine lubricants. The strategy was brilliant in its simplicity. Pennzoil would own the gasoline engine market, while Rotella would dominate diesel and heavy-duty applications. Today, Shell Rotella claims over 40% market share advantage over competitors in 15W40 and 5W40 diesel oil viscosities. Pennzoil holds 24% of total passenger car motor oil volume in the United States. This is not just corporate strategy, it is a reflection of fundamental engineering reality. Diesel engines and gasoline engines operate in completely different worlds, and attempting to use the wrong oil in either one creates problems that can destroy an engine worth tens of thousands of dollars. The reason diesel engines demand specialized oils like Rotella comes down to compression ratios and what happens inside the combustion chamber. Diesel engines operate with compression ratios reaching 14 to 1 up to 25 to 1, compared to 8 to 1 through 12 to 1 for gasoline engines. When you compress air that dramatically, temperatures inside the cylinder reach levels high enough to ignite fuel spontaneously without any spark plug. This compression ignition creates a cascade of lubrication challenges that would overwhelm conventional motor oils within thousands of miles. The most critical difference is soot production. Diesel combustion produces microscopic carbon particles about 0.03 microns in size that accumulate in engine oil throughout the service interval. Without adequate dispersant additives, these particles agglomerate into larger abrasive compounds that accelerate bearing wear, ring wear, and cylinder wear. Diesel oils contain 3 to 4 times more detergent and dispersant additives than gasoline oils, specifically to suspend these contaminants and prevent sludge formation. Acid neutralization presents another key challenge that gasoline oils simply aren't designed to handle. Diesel combustion generates sulfuric acid from fuel sulfur and nitrogen oxides from high-temperature operation. The oil must neutralize these acids before they corrode bearing surfaces and accelerate component wear. Diesel oils compensate with elevated total base numbers, typically 10 to 15 milligrams of potassium hydroxide per gram, compared to 6 to 8 milligrams for gasoline oils. This alkalinity reserve, provided primarily by calcium and magnesium sulfonates, acts like a chemical buffer that keeps the oil from turning acidic. When diesel oil goes into a gasoline engine, all that extra alkalinity and those elevated detergent levels can actually harm catalytic converters. The phosphorus content in diesel oils, typically around 1,100 parts per million, will poison a gasoline vehicle's catalyst over time. This is why Shell Rotella products carry explicit warnings against use in catalyst-equipped gasoline engines. The chemistry that protects a diesel engine becomes toxic to the emissions control systems on a gasoline vehicle. Modern turbocharged diesels add yet another layer of complexity that demands specialized lubrication. Turbocharger shafts spin at 100,000 to 200,000 revolutions per minute, with turbine temperatures exceeding 1,000 degrees Celsius. The oil must simultaneously lubricate bearings floating on microscopically thin oil films and carry heat away from the turbo assembly. Contaminated or thermally degraded oil remains the primary cause of turbocharger failure. Garrett Motion, a leading turbo manufacturer, notes that it takes just a few seconds for a lack of oil to cause catastrophic damage. When you consider that a replacement turbocharger can cost $3,000 to $5,000 installed, the importance of using oil engineered specifically for these conditions becomes crystal clear. This is where the engineering behind Shell Rotella separates it from conventional motor oils. The thermal stability required to survive sustained turbocharger temperatures is extreme, and it demands synthetic base stocks or carefully refined conventional oils with robust additive packages. Shell Rotella's product hierarchy reflects different operating conditions and budget requirements, ranging from entry-level conventional oils to premium full synthetics. Shell Rotella T4, triple protection, represents the conventional workhorse, available primarily in 15W40 and 10W30 viscosities. Using Group 3 mineral base oils with Shell's proprietary additive package, T4 provides what Shell markets as triple protection against wear, deposits, and oil breakdown. The specifications tell the engineering story. T4 delivers kinematic viscosity of 15 square millimeters per second at 100 degrees Celsius, total base number of 10.1 milligrams of potassium hydroxide per gram, and pour point of -36 degrees Celsius. T4 meets APICK4 standards and carries approvals from Caterpillar, Cummins, Detroit Diesel, Mack, Volvo, and other major engine manufacturers. Shell offers warranties up to 10 years or 300,000 miles when T4 is used exclusively, which represents extraordinary confidence in the product's protective capabilities. Shell Rotella T5. Synthetic blend occupies the mid-tier position, combining synthetic and conventional base oils for improved cold flow properties and fuel economy. The synthetic blend delivers 1.6 to 2% fuel savings compared to conventional 15W40 oils, while providing 44% better wear protection than APICK4 minimum requirements. Shell's testing demonstrates protection well beyond 50,000-mile original equipment manufacturer drain intervals. For fleet operators and owner-operators running modern diesel engines, that fuel economy improvement translates directly to the bottom line savings. At current diesel prices averaging $3.75 per gallon, a truck running 50,000 miles annually at 6 miles per gallon would save approximately 62 gallons per year with T5's 2% improvement. That's $230 in annual fuel savings, which more than offsets the higher oil cost compared to conventional T4. Shell Rotella T6 full synthetic represents Shell's premium diesel lubricant, available in 0W40, 5W40, and 15W40 viscosities. The full synthetic formulation achieves remarkable pour points as low as -51 degrees Celsius, compared to -36 degrees Celsius for T4, enabling reliable cold starts in extreme conditions. Anyone who has tried starting a diesel in Canadian winter or Alaska conditions understands why pour point matters. When oil refuses to flow at cold temperatures, the engine cranks without lubrication, reaching critical components. T6 delivers up to 34% better wear protection compared to APICI4 plus requirements and 70% better oxidation resistance. Shell extends warranties to 15 years or 500,000 miles for T6 users, which speaks volumes about the product's engineered durability. The synthetic base stocks in T6 resist thermal breakdown at sustained high temperatures that would rapidly degrade conventional oils. Shell Rotella T6 multi-vehicle represents a unique formulation that meets both APICK4 for diesel engines and APISN for gasoline engines, using lower phosphorus levels to protect gasoline catalytic converters. This dual certification suits mixed fleets operating both diesel and gasoline vehicles on a single oil specification. The multi-vehicle variant claims 2.8% fuel economy improvement versus conventional 15W40 oils. However, it is crucial to understand that this dual rating required compromises in the formulation. The reduced phosphorus content means slightly less extreme pressure protection compared to diesel-only Rotella products. For purely diesel applications, the standard T6 formulations provide superior protection. The detailed specifications of Shell Rotella products illuminate why diesel oils perform so differently than gasoline engine oils. Rotella products contain approximately 1,200 parts per million zinc and 1,100 parts per million phosphorus, in the form of ZEDDP, zinc dialkyl dithiophosphate. This provides extreme pressure protection for heavily loaded components like camshafts, lifters, and piston rings. This concentration exceeds what is safe for gasoline vehicle catalytic converters, which explains the explicit warnings about not using Rotella in catalyst-equipped gasoline engines. The additive package serves multiple functions simultaneously. Multifunctional dispersants control soot and contaminants while preventing sludge formation. Calcium and magnesium-based detergents maintain surface cleanliness and neutralize combustion acids. Antioxidants resist thermal breakdown at temperatures that would destroy conventional oils. Friction modifiers and synthetic grades improve fuel economy, and anti-foaming agents prevent the air entrainment that would compromise film strength. Modern diesel after-treatment systems require careful additive balance that fundamentally changed diesel oil formulation after 2007. All on road, heavy-duty diesel engines now use oils meeting low SAPS requirements, meaning low sulfated ash, phosphorus, and sulfur. The limits restrict sulfated ash to 1% or less, phosphorus to 0.12% or less, and sulfur to 0.4% or less. These limits protect diesel particulate filters from ash accumulation and prevent catalyst poisoning. The challenge for oil engineers was maintaining protection levels while reducing the very additives that provided that protection. Shell Rotella products meet these requirements through careful reformulation, though ash buildup over time still necessitates periodic diesel particulate filter cleaning. The particulate filter traps soot to meet EPA standards, but that trapped material eventually requires removal. The American Petroleum Institute CK4 specification, introduced December 2016, represents the current standard for heavy-duty diesel engine oils. CK4 requires enhanced protection against oxidation, viscosity loss from shear stress, oil aeration, and deposits, while maintaining compatibility with 2007 era and later after-treatment systems. All current Shell Rotella diesel products meet or exceed CK4 requirements. APIFA4 offers a fuel economy-focused alternative, with lower high-temperature, high-shear viscosity of 2.9 to 3.2 centipoise versus 3.5 centipoise or higher for CK4. However, FA4 oils are not backward compatible and should only be used in 2017 or newer engines specifically designed for lower viscosity lubricants. Detroit Diesel was an early adopter, factory filling many engines with FA4 oils. Using FA4 in older engines risks inadequate film strength under load, potentially causing accelerated wear. European specifications follow different conventions through ACEA, the European Automobile Manufacturers Association. The current ACEA E8 and E11 categories address heavy-duty diesel engines with aftertreatment, while C-Class specifications from C1 through C7 target light-duty diesels with particulate filters. Unlike API categories, ACEA heavy-duty categories are not backward compatible. An E8 oil may not suit engines requiring E4 or E7 formulations due to different additive chemistry. Original equipment manufacturer specifications often exceed API and ACEA requirements. Cummins CES 20086, Detroit Diesel DFS 93 K222, Caterpillar ECF3, Volvo 5DS 4.5, and Mack EOS 4.5 represent current top-tier approvals that enable extended drain intervals. Shell Rotella T4, T5, and T6 carry most of these approvals. The heavy-duty diesel oil market features several well-established competitors, each with distinct positioning strategies. Mobil Delvac claims the widest use in commercial trucking, backed by ExxonMobil's more than 80 million kilometers of CK4 and FA4 field testing. Chevron Delo offers the innovative Delo 600ADF with 60% less metallic components for maximum diesel particulate filter protection. Valvoline Premium Blue leverages its exclusive Cummins endorsement and proprietary dispersive polymer technology, making it the only oil Cummins officially recommends by name. This endorsement carries weight in the trucking industry, where Cummins powers a substantial portion of over-the-road tractors. Independent testing by the Petroleum Quality Institute of America compared Shell Rotella T4, Mobil Delvac 1300 Super, and Chevron Delo 400 SDE, all 15W40 CK4 products. The results showed all three products met SAEJ 300 viscosity specifications and API service category claims, with no significant quality differences identified in laboratory analysis. This finding aligns with fleet operator consensus and experienced truckers frequently report running different major brands through used oil analysis programs with comparable results. The reality is that all major diesel oil brands perform adequately when changed at appropriate intervals. Price and availability often drive purchasing decisions, with retail price differences between major brands typically amounting to 40 to 60 cents per gallon. Shell Rotella's advantages include exceptional retail availability at virtually every truck stop and auto parts store, JASOMA and MA2 certification for motorcycle wet clutch compatibility, and the broadest original equipment manufacturer approval matrix among consumer-accessible products. Shell Rotella's origins trace to post-World War II America, when expanding commercial trucking and industrial operations demanded robust diesel lubrication. Shell introduced its first diesel engine oils in the 1930s, gaining traction among truckers and farmers. Archival promotional materials document Shell Rotella marketing by 1950, with early formulations emphasizing single-grade viscosities such as SAE 30, tailored for heavy equipment. The brand became formally established during the 1970s, as recognition grew that diesel engines required fundamentally different lubrication than gasoline power plants. Major reformulations tracked evolving emissions regulations. The 2006 introduction of API-C J4 prompted significant changes to accommodate diesel particulate filters entering the market with 2007 model year engines. The December 2016 launch of API-C K4 and FA4 specifications triggered another comprehensive portfolio update across T4, T5, and T6 product lines. Looking ahead, the industry expects licensing for the API PC12 specification in 2027, and Shell has launched a PC12 Knowledge Hub to prepare customers for next-generation requirements. These ongoing specification updates reflect the continuing evolution of diesel engine technology and emissions controls. Each new specification typically requires reformulation to balance protection with after-treatment compatibility. For diesel owners, this means staying informed about which specification their engine requires and ensuring their oil meets or exceeds that standard. The practical implications of using the wrong oil in a diesel engine can be severe and expensive. Running gasoline engine oil in a diesel engine fails to provide adequate soot handling capability. The dispersant package in gasoline oil simply cannot suspend the volume of carbon particles generated by diesel combustion. Within a few thousand miles, those particles begin agglomerating and forming abrasive compounds. The engine develops deposits on piston rings, potentially causing ring sticking and blow-by. Valve trains accumulate sludge. Bearing surfaces experience accelerated wear from inadequate acid neutralization. The total base number in gasoline oil depletes rapidly, allowing combustion acids to attack bearing materials. A diesel engine running on gasoline oil might appear to operate normally for several thousand miles, but internal damage accumulates silently. By the time symptoms become apparent, such as oil pressure drops, unusual noises, or performance loss, significant damage already exists. Conversely, using diesel oil like Rotella in a modern gasoline engine with a catalytic converter creates a different set of problems. The elevated zinc and phosphorus content, necessary for diesel engine protection, acts as a poison to three-way catalysts. Over thousands of miles, these metallic compounds accumulate on the catalyst substrate, blocking active sites and reducing conversion efficiency. The vehicle gradually fails emission standards as the catalyst becomes less effective at reducing nitrogen oxides, carbon monoxide, and unburned hydrocarbons. Catalyst replacement costs range from $800 to $2,500 depending on the vehicle. Additionally, the high detergent levels in diesel oil can cause excessive foam in gasoline engines, particularly those with high revving characteristics. This foam can compromise oil pump efficiency and reduce lubrication effectiveness. Shell Rotella gas truck represents an interesting exception that proves the rule about diesel and gasoline oil differences. Despite carrying the Rotella brand name, gas truck is formulated exclusively for gasoline-powered pickup trucks and sport utility vehicles. It should never be used in diesel engines. Available in 0W20, 5W20, and 5W30 viscosities, gas truck carries APISN+ and Dexos approvals, with completely different additive chemistry optimized for spark ignition engines. The phosphorus content is dramatically lower to protect catalytic converters. The dispersant package is calibrated for gasoline combustion byproducts rather than diesel soot. Shell markets this under the Rotella brand because pickup truck owners already associate Rotella with heavy-duty protection, but the formulation has nothing in common with diesel Rotella products. Using gas truck in a diesel engine would provide inadequate protection against soot, acid, and wear. Professional mechanics and fleet managers generally agree that all major diesel oil brands from reputable manufacturers perform adequately when changed at appropriate intervals. Extended drain intervals enabled by synthetic oils and robust additive packages still require used oil analysis to confirm the oil has not reached its limit. Factors like fuel quality, operating conditions, idle time, and engine condition all affect how quickly oil degrades. A truck running cross-country at steady highway speeds degrades oil more slowly than a delivery truck, making constant stops and starts in city traffic. Cold starts accelerate oil contamination because the engine runs rich before reaching operating temperature, introducing more fuel dilution. Short trips prevent the engine from reaching temperatures that evaporate accumulated moisture and fuel. The economics of diesel oil selection involve more than purchase price per gallon. Synthetic oils like Rotella T6 command premium pricing, typically $8 to $12 more per oil change than conventional T4. However, synthetic oils enable extended drain intervals that can offset the higher cost. A truck changing conventional oil every 10,000 miles requires 5 oil changes over 50,000 miles. Switching to synthetic oil with 20,000-mile intervals reduces that to 2.5 changes. The labor savings alone can justify the synthetic premium for commercial operations. Additionally, the improved fuel economy from synthetic oils, though modest at 1.6 to 2.8%, accumulates significantly over high mileage operation. Fleet operators running millions of miles annually calculate these economics precisely. For owner-operators and individual diesel truck owners, Shell Rotella's exceptional retail availability represents a practical advantage that should not be underestimated. Running a diesel engine out of oil, or with severely degraded oil, for even short periods causes damage that accumulates over time. Being able to purchase quality diesel oil at virtually any truck stop, auto parts store, or big box retailer means never having an excuse to run low or defer an oil change. This universal availability also matters for resale value. Prospective buyers of used diesel trucks value documented maintenance with recognized brands. Service records showing consistent use of Shell Rotella, Mobile Delvac, or Chevron Delo provide confidence that the engine received proper lubrication throughout its life. The relationship between Shell Rotella and Pennzoil under Shell Oil Company's corporate umbrella illustrates how a single company can successfully serve dramatically different markets through focused brand strategy. Pennzoil dominates passenger car motor oils for gasoline engines through extensive retail presence and racing sponsorships that build consumer awareness. Rotella owns the diesel and heavy-duty segment through technical credibility and original equipment manufacturer approvals that fleet managers and commercial operators demand. Neither brand attempts to cross into the other's territory because the engineering requirements differ so fundamentally. This strategic separation, established when Shell acquired Pennzoil Quaker State for $2.9 billion in 2002, has proven remarkably successful. Shell maintains its position as the world's leading finished lubricant supplier for 16 consecutive years, according to Klein and Company research. Understanding why diesel engines need specialized oils like Shell Rotella rather than conventional motor oils comes down to recognizing that compression ignition creates a completely different operating environment than spark ignition. The extreme compression ratios, massive soot generation, acidic combustion byproducts, and turbocharger demands of diesel operation require lubricants engineered specifically for these challenges. Using gasoline engine oil in a diesel or diesel oil in a catalyst-equipped gasoline engine creates problems ranging from accelerated wear to emissions system damage. Shell Rotella's tiered product line, from economical T4 through premium T6, offers options matching various operating conditions and budgets while meeting the comprehensive certifications that ensure proper protection. The major diesel oil brands perform comparably in laboratory testing, but Rotella's exceptional availability, broad approvals, and decades of diesel-specific development make it a reliable choice for everything from pickup trucks to commercial fleets.